As we all know, if we launch an object with a given initial speed, the object's trajectory will be a parabola. If we want to reach a certain if we want to reach the maximum distance along a given line of sight, what should that angle of launch be? Also, what will be the maximum range that we can reach, and what will be the flight time? What if we want to hit a target at a specific distance along that line of sight? What are the two trajectories, or the two launch angles that will hit that? And what will be the times of flight? Back to the question of the maximum range along a given line of sight. Here are different lines of sight, and this is our launch point. You can see that these maximum distances along each line of sight lie along a curve. What will that curve be? What is its equation? These are the subjects, or some of them, that we will be treating in this document that we present here, which is part 2 of a guide to David Hestenes' treatment or geometric algebra treatment of constant acceleration motion, or parabolic motion. And in this document, we want this guide to be as useful as possible to students. So please be free with your comments and criticisms. We'll incorporate those in a later version of this document. When I refer to we, I mean the LinkedIn group Pre-University Geometric Algebra, which I hope you will consider joining. So the portion of Hestenes' book that we treat in this document is entitled Maximum Range, but actually that section treats much more than just that single topic. And that, in fact, in a certain sense, is one of the weaknesses of this section. David Hestenes was under, pressure to keep his book down to a manageable length. So he could not provide, or he could not provide really the structure or the thread of a lot of what he was doing. There just wasn't space to present all that. So we will be doing a lot of that here. More specifically, we'll give an idea of where Hestenes was heading at each point in his section, and some of the ideas that he apparently used to find those ways to go about it. So here we're just going to go and scroll through the document. Of course, if you want to learn how to do this, you'll have to consult this, and I've uploaded it, I've provided a link in the video description where you can obtain this document, of course, for free. So let's scroll through here. There's a table of contents, of course, an introduction, and comments on the scope of this document. We don't treat the entirety of the maximum range section. The remainder of it will be treated in a third video. So let's get into it here. We begin with a section on what we will see in this document, and I want to emphasize this part here. We'll show, or we'll present, some sanity checks of intermediate results. These are important especially for someone who's new to geometric algebra, so they can kind of find out whether they're on the right track before they go all the way to reducing the formula to a final version. And there will also be a validation of the solutions that are obtained via GeoGebra construction. So we'll go through the rest of this fairly quickly. There is a detailed presentation of ideas that we'll use. And I want to note here some geometric algebra identities, which are important. We won't go into them here, but this document does present references where you can find the derivations, and also here we just derived that because it's a short derivation. So getting into it here, the first subject is the launch direction that gives a maximum range. and then finding that maximum range. And it turns out that the direction of launch that gives a maximum range bisects the direction of the line of sight that interests us and vertically upward, which is kind of a neat result. So if you want to find the maximum range, it's just the bisector of the line of sight that interests us and vertically upward. Continuing here, we want to find the region of space, and that turns out to be a parabola, and Hestenes demonstrates that very simply by using some results of analytic geometry that he presented earlier in the book. So that's actually quite brief. Proceeding further here, what about the launch direction or launch directions for a target that's along that line of sight but not at the maximum range? That's treated here again in quite a bit of detail for people who are new to the subject. And when we're all done with all that, it turns out that the two launch directions for reaching a target at less than the maximum range are actually symmetric to each other with respect to the direction for the maximum range, which is kind of a neat result. So finally then there's a GeoGebra construction for testing the formulas, and let's take a look at that just briefly. You'll be able to check solutions for the maximum range and for a target at less than the maximum range. And also here to check the predicted maximum range and flight times and such and launch directions against the true directions and times, etc. And also if you want to find out whether, well, is this really the maximum range along this line of sight, you can check that too here by playing with this other vector. So please again be free with your suggestions and criticisms. We want this resource to be as useful as possible, and I hope that you'll consider joining our group, Pre-University Geometric Algebra, and thank you for your time. I look forward to your